Earthquakes. Today we are going to learn about the meaning of earthquakes, causes of earthquakes, measurement to be taken, and effects, that is destructive and constructive effects of earthquake zones of the world. What is an earthquake? An earthquake is the vibration or shaking or trembling of earth produced by sudden release of energy, usually associated with faulting or breaking of rock stratus, continuing adjustment of position resulting in aftershocks. Then energy is radiated like waves in all directions from the source, that is the focus of earthquake. Seismographs are the instrument which records the continuous event of earthquake. Causes of earthquake. Natural cause, plate tectonic movements, volcanic eruption, folding and faulting in rocks, imbalance on the earth's surface. Man-made cause, pumping for groundwater, pumping for mineral oil, deep underground mining, rock blasting using dynamite, nuclear explosion, hydrostatic pressure. Plate tectonics. Tectonic plates floating on asthenosphere. We have already learned in chapter number 4 about the asthenosphere. Earthquakes occur at the boundaries where plates diverge or converge. Here we are having this diverging boundary or converging boundary. Even when they slip past each other, two plates slipping past each other, then also we get earthquake. Folding and faulting occurs at these plate boundaries, whether the plates are moving away from each other or striking towards each other. Then divergent boundaries, that is moderate earthquake, slowly it takes place, whereas convergent boundaries, higher magnitude of earthquakes. That is, divergent boundary means plates are moving away from each other. For example, Atlantic ridge. Or convergent boundaries, that is, ring of fire of Pacific areas like oceanic to continental, oceanic to oceanic, continental to continental, even transform boundaries like plates sliding past each other. Here we can see that earthquake at divergent boundary in Iceland, how it has been diverged from each other and earthquake had taken place. Volcanic eruptions. Magma under the crust tries to push upwards from below the surface of the earth with great force. As it is coming, whether it is converging plates or diverging plates, as it is pushing up, it is coming out with great force and causing earthquake. Folding and faulting. Horizontal and vertical movements in the crust will cause earthquake. Compressional and tensional forces create these movements. Here you can see slipping or compression fault or diversion fault will be there. Fault crack in the crust is forming here, and then the crustal blocks move up, down or sideways along the faults. Stored energy is released through the cracks. Stored energy, that is radioactive materials which is continuously acting within the Earth's surface inside the Earth's interior, those energy is released through these faults and the vibration created. In the folding area like compressional force, there also this subduction zone like Himalayas, there also when Indian plate is moving towards the Asian plate or Eurasian plate, Himalayan area we are having earthquake because of this. For example, Nepal earthquake. Earthquakes are caused by sudden release of accumulated strain energy along faults. These faults through which earthquake is taking place as well as it is releasing the energy. Rocks on side of fault are deformed by tectonic force. Here you can see that how this flat strata is built up of strain and then it is getting cracked and moving past each other, and you can see the river course is also changed over here. Earthquake mechanism. Slip starts, that is the fault starts at the weakest point. Wherever the crack is forming, that is the weakest point. And then the below it is the focus. And earthquake occurs as the deformed rock springs back to its original shape. That is elastic rebound. When there is a shaking, that time the rock strata it start because of the uh, original position they want to achieve, they spring back. That is the theory of inertia. But though they cannot come to that position, but because of the springing up and down or sideways, the earthquake mechanism starts. The motion moves the neighboring rocks. Like here, for example, strike slip fault quake in California. You can see the picture over there, over here, how this particular straight line has deformed. Here, this Californian region directly, this area is fault area. Here you can see the strike slip fault in California with this red mark I have shown you. The how much the distance has been slipped. Now normal fault, one side is slipped down or slipped up, forced up. The quake in Nevada, because of this also the earthquake has taken place. Or the reverse fault quake in Japan. It is coming towards each other, the two plates, continental to continental or oceanic to continental. One went inside the other and the reverse fault has taken place. Next one, man-made causes. Pumping for groundwater or mineral oil, deep underground mining, rock blasting using dynamite, nuclear explosion, hydrostatic pressure. Now look at these pictures. When the well is digged in, that time because of this the fracture is also formed within the crust. Over here also, whether it is water or mineral oil, but the fracture has formed. Suppose these areas, this particular water gets finished or vacuum is created, that time this rock strata will fall down because of the disbalance. And upper rock strata, if it falls down because of disbalance, the whole area will have for face the or experience the earthquake. Over here you can see if maximum water like in the dam is reserved, that is pressuring the lower, that is the parent rock or underlying rocks, and because of that fractures are forming. If it is taking out the masses because of the construction purpose or mining purpose over here, then the vacuum is created under upper layer rocks are pressurizing, and then over here you will have earthquake. Same way over here, because of this particular area, it was adjusted, the rocks were adjusted to a particular balance, but when the upper layer has been taken out or removing the mass from this area, then upper layers pressure becomes less and lower layer pressure becomes more, and crack starts forming over there. If it is becoming more, then we'll have volcanic eruption as well as earthquake. Like Storage of water in big reservoirs, especially the seismic zones. For example, Koyna Dam in India. Several hundred millions of tons of water blocked by the dam cause earthquake by weakening the fault. Over here you can see it. Anatomy of earthquakes. Earthquake focus and epicenter. Focus from where the actual earthquake wave starts. Like the point within earth where faulting begins is the focus, or it is called hypocenter. Whereas the point directly above the focus. Over here you can see directly above the focus on the surface is called epicenter. To remember, E and F, that is alphabetical order, E, F, epicenter and focus. Earthquakes measurement seismology. It is called, whatever we learn about the earthquake, it is called seismology. Seismometer, that is the instrument that record the seismic waves. But what is seismograph? Continuously it is recording earthquake events. This drum, it is continuously rotating, and because of the shaking of the ground and the instrument which is attached to it, this particular hinged, that is suspended mass, is continuously recording the earthquake waves. The seismograph designed to record vertical ground motion. Now measuring earthquake, two types, depending on intensity, depending on magnitude. Depending on intensity, that is Mercalli scale, based on the amount of damage, especially depending on the observation. Intensity depends on total amount of energy released, distance from the epicenter, type of rocks present over there. Drawback of this kind of scale is that destruction may not be true measure of earthquake's actual severity, because it depends only on observation, and it may be felt, the earthquake may be felt in different areas. Nearer places will have more destruction, whereas further places will have less destruction. Magnitude estimates the amount of energy released by the earthquake. It is called Richter scale, introduced by Charles Richter in 1935, based on amplitude of largest seismic wave recorded. Each unit of Richter magnitude corresponds how much? 10 times increase in wave amplitude and 32 times increase in energy releasing. Here we can see whenever the earthquakes reaches the earth's surface, first we feel the P waves, and then you can see this area difference is there instead of straight line, that is the S waves. And when the S waves are after some time is showing the higher magnitude, that is the on the surface, whatever we are feeling, that is the surface waves. Measuring earthquakes, Richter scale and Mercalli scale. Mercalli scale 1 and 2, that is almost nobody feels it. That is felt by very few people. And 2.5 is generally not felt for people, but sometimes it is recorded in the seismometer. 3, 4, 5 in Mercalli scale, tremor noticed by many, but they often do not realize. Now, felt indoors by many, feels like truck has struck the building, or felt by nearly everyone. Many people awaken, swaying trees or poles may be observed. Whereas 3.5 over here felt by many people. So you can say 3 to 5 in Mercalli scale or 3.5 in Richter scale is felt by many people. Next one, 4.5 in Richter scale, some local damage will be there. Same thing for 6, 7 for the Mercalli scale. Mercalli scale 8, 9 will be same like destruction in 6 grade Richter scale, that is destructive earthquake. To some extent, the destruction will be there. Next one is coming for 10, measurement 10 in Mercalli scale or 7 in Richter scale is major earthquake. 11 and 12 in Mercalli scale will be all structures will fall, bridges will wreck, very wide cracks in the ground, total destruction, that is great earthquakes. Same thing, 8 and above will be the great earthquake for Richter scale. Parameters of differences in Mercalli scale and Richter scale. Measures. The effect can be caused by an earthquake and energy released by an earthquake. Two different things. Yeah, Mercalli scale is observing that effect. Richter scale is calculating the energy released. Next one, measuring tool by observation by Mercalli scale. Richter scale is seismograph. Calculation by Mercalli scale quantified from observation of the effects of earthquake on the surface, on humans, objects, man-made structures, whereas based on 10 logarithm scale, that is mathematical calculation obtained by calculating logarithm of the amplitude of waves. Scale, Mercalli scale 1 which is not felt, 2, 12, that is total destruction. Whereas Richter scale 2 to 10, that is 2 is not that much recorded, not felt much. 3 earthquake, and after that 10 times stronger than the 2, that is tenfold from the previous number. Consistency of Mercalli scale varies depending on distance from epicenter, whereas Richter scale varies different distances from the epicenter, but one value is given for the earthquake as a whole. Types of seismic waves. Two types. One is body waves, which is interior part of the earth, and surface waves on the surface of the earth. Body waves, that is P waves and S waves, whereas surface waves are R waves and L waves. Let us study the body waves. Here you can see the direction of propagation of P waves, that is the primary waves, and the secondary waves. We can see travel through Earth's interior. These body waves, two types: primary waves, mode of depending on the travel of movement, or depending on the waves traveling, that is primary waves, and S waves or secondary waves or shear waves. Primary waves are fastest waves, directly it is coming, and it is like compression and refraction, push-pull motion, travel through solids, liquid, gas, and it is a compressional wave. Material movement is in the same direction as the wave is moving. Here you can see. Whereas secondary waves, slower than P waves, reaches the earth's surface later than the P waves, travel through solids only, and move material perpendicular to the wave. Now you can see over here it is perpendicular to the wave, whereas P waves are along the wave. Now S waves moves at right angles to their direction of travel. Here S waves you can see it is moving towards Earth's surface, but it is moving perpendicular to the Earth's surface, whereas L waves directly along the line of the waves. Surface waves, R waves and L waves. The great destruction takes place only, we are talking about the surface wave, that is surface of the earth. It is of high amplitude, travel just below or along the ground surface, slower than the body waves, rolling and side to side movement. No straight movement is there. and especially damaging to buildings. Yeah, you can see how the buildings are getting damaged. One is R waves rolling and coming forward, moving forward. So up and down movement is over here, whereas it is sideways movement is taking place. Same way, love waves always sideways, movement particles are moving sideways, whereas Rayleigh wave will be rolling and moving, rolling and moving. How is an earthquake's epicenter located? Seismic waves behavior. P waves arrive first, then S waves, then L waves and R waves. After an earthquake, the difference in arrival times at a seismograph station can be used to calculate the distance from the seismograph to the epicenter. How much time it is taking, how much time it's taking for the P waves or S waves or the L and R waves. According to that, the calculation is taken place. Earthquakes effect and destructive and constructive. Destructive effects. Ground surface is deformed, damage to all types of structures, towns and cities. Groundwater pipes break, electric poles fall, telephone wires damaged, sewer system collapses, bursting of gas pipes, live electric wires, that is electrification may take place if there is water or flood during that time. It is much more dangerous. Then damage to blast furnaces, then devastating fires will take place, then landslides, then flash floods, then tsunamis, then loss of human and animal life will take place. Here we can see fires caused in 1906 San Francisco's earthquake, or the damage to the buildings, or the changing of the course of the river is also part of it. That means it is slip away from each other or towards each other. Liquefaction, that is also part of earthquake. Suppose lower part of the upper rock strata is having much more water content in the soil. That during the earthquake, upper strata's pressure will be there and devastating earthquake will take place. Here you can see how it has fallen down because lower strata was having liquefaction. Tsunami or seismic sea waves, also called tidal waves, result from push of underwater fault or undersea landslide. Very destructive. Tsunamis are actually huge extending form of fault on sea floor, through which sometimes volcanoes also erupt, like in Indonesia. Effects of earthquake, constructive effects, stored energy of interior of earth is released and maintaining the earth in its proper shape. Landslides from lakes by creating depression. Here one example, Quake Lake in southwestern Montana in United States, because of the landslide due to earthquake. This water from the surrounding area, when the landslide has taken place, after that many years it took, but water from the surrounding area got collected in this depression where landslide has taken place and the lake has formed. Then coastal areas are uplifted. Here you can see previously it was a straight continental slope, but now because of the fracture, coastal area has lifted up. Then structural plains of Coromandel Coast or Mississippi Basin is the example of it. Then it provides data about structure and interior part of the earth. How? Now, seismology helps us understand Earth's interior. We have learned earlier also, due to changes, rigidity, density, elasticity, and seismic waves. In these P waves and S waves, S waves will not cross the solids, whereas P waves will cross all the solid, liquid and the gas. Because of the different types of waves and how they travel, we have a very detailed picture of the interior of the Earth. The same seismic waves can help us to find out the oil reserves and gas deposits under the Earth crust through seismic air gun. Major seismic belts of the Earth. 70% in the Southern Pacific Mountain Belt, that is the Ring of Fire, and then 20% in the Mid-World Mountain Belt. Mid-World Mountain Belt through the Mediterranean region, Alps, and other fold mountains over there, and then it Caucasus Mountain, Zagros and Elburz, and then Himalayan belt, which is again through the southern side when it has turned and joined with the Indonesian belt, and again it joined with the Ring of Fire. 10% occur in mid-Atlantic ridge belt, that is the divergent boundary. Here you can see Iceland is coming within that area. Zones of folding and faulting, like young fold mountain belts, East African belt, these areas are also coming under earthquake belt. And zones of active volcanoes, for example, this Pacific Ring of Fire. These are the major areas of seismic activity. Earthquake prediction. It includes laboratory field studies of rocks before, during and after earthquakes, minority activities along major faults. Long-range forecast can be done to some extent, like calculation probability of a certain magnitude earthquake occurring over a given period of time. But short-range prediction is still now under research, presently not much of success. Now, how do they do this long-range focus? Because, for example, the San Andreas fault, they have seen how much percentage where the fault has taken place, when it has taken place. Accordingly, they can predict, okay, along this fault, somewhere the fault will form and earthquake will be taking place. Same way in the Aleutian belt or Alaska or the northern part of USA's northwest USA, we can see different year they have seen where it is taking place. Accordingly, they can predict. In India, as it has been told that this particular mid-world mountain belts region is going, and along this line, that is Himalayan range, Karakoram range, or the mid-world mountain, other areas are there, Hindu Kush and all. This area, according to that, we can predict. For example, this in Dehradun, we have this facility of counting through seismograph, the seismology of India. Next one, can earthquake be controlled? They say some have suggested that pumping fluids into seismic gaps, if there is any gap, and if fluid like water or something is dumped over there, will cause small earthquake instead of large ones, but it cannot be prevented as such. It is a continuous process.